Hello and welcome. I am Melly Annamalai, a product manager with Oracle with a database organization, and I'm very excited to be here with you today to talk about graphs. I will be talking about why graphs are important and interesting, where graphs are used today, and some of the key components of the graph feature of Oracle database. In short, all about graphs. When you model your data as a graph, it enables you to explicitly model the relationships and connections between your data entities, giving you a different way of looking at your data. When you, let's say, store your data as tables in rows and columns, some of these relationships might be implicit. For example, you might have foreign key constraints between tables. But when you model your data as a graph, it gives you the ability to make these connections and relationships between data entities explicit and gives you the ability to then use graph algorithms and graph pattern matching queries on your data to get new insights. So let's take an example here. There are three tables representing customer sales data: customer table, movie table, and the cus sales table that tells you which customer rented which movie. Customers are data entities and naturally become vertices in your graph. So every row in the customer table becomes a vertex. Similarly, the movie table gives you a set of vertices, and the cus sales table, which specifies the relationship between the two tables, that this customer rented this particular movie, becomes the relationship between them and can be modeled as an edge in the graph. So in this way, any data set can be modeled as a graph because any data set has relationships built in, any data set has relationships available in it. Here's another example of bank financial transactions. You have a table, bank accounts. You have another table, bank transactions, which tell you when a cash transfer was made from one account to another. Bank accounts become vertices in your graph, and every time a cash transfer happens between two accounts, that's a relationship between the accounts, and that can be modeled as an edge. So you can model your data this way to get a cash transfer bank graph. So when you model your data as a graph like this, you could do things like this to highlight some of the things that you can, some of the types of analytics and graph pattern matching queries that you can run with your data. The two vertices highlighted here are vertices with a high number of incoming and outgoing edges. So in the cash transfer context, perhaps these are vertices which have a lot of cash transfers flowing through them. And here are two other vertices which similarly have a high number of cash transfers flowing through them. So you can see with graph queries, you can see whether there is a path, a direct path between these two vertices. So is there a direct connection, a cash transfer connection between two vertices that have a large number of cash transfers flowing through them? That could be an interesting insight. And is there a cash transfer that starts from one of these vertices, goes to another vertex, and then comes back to the source vertex? So this is a cycle. Like, is there a cycle in the graph? Can I find out all the cycles I have in my graph that start with a particular account, and so on and so forth? So what are some of the business problems that can be addressed with the help of graph analytics? Money laundering is an example that frequently comes up when we talk to financial institutions. So they're interested in knowing whether money is moving in unnatural patterns or in moving in a cycle, because folks want to hide where the money is coming from and make it appear as though it's coming from a different source. So a cycle is a classic way to detect such money movement, and graphs are really good at detecting such cycles. In manufacturing or network management, You can model your bill of materials as a graph. You can model your network as a graph to do what if analysis, like what will happen if it change the design of a component? What will happen if a network node goes down? With graphs, you can do path analysis to look at the impact of these events, not just on the vertices immediately connected to this vertex, but analyze the impact on all of these other components that are indirectly connected to this vertex. And then there could be the question of which customers have similar patterns with these similar behavioral patterns when compared to each other, and especially if they're different from some other customers that I have. So which customers are closer together, closer to each other behaviorally than they are to some other customers. Graphs are really good at identifying clusters. So if you model your customer behavioral patterns as a graph, you can identify subgraphs within the graph where you have vertices more tightly connected to each other. Can I derive new relationships from existing connections? So you can do path analysis to derive new connections, to derive connections that would have been indirect without graph analysis. And you can also use ontology. So ontologies are a way to capture knowledge from a domain, and they're used by knowledge graphs to infer new information from existing data. And graphs also have the flexibility of having a flexible, graphs also have a flexible schema. So if you have lots of new attributes coming in when you're managing your assets, and you don't want to change the underlying database structure, but you want to be able to generate new pieces of collateral from existing assets that you have, you can use graphs to represent these attributes. And we'll see an example of this later when we talk about customer use cases. So when you analyze your data based on graphs, you also have the visual component, right? Is there a cycle that represents how money is moved in this set of financial transactions? What are the reachable paths? So graph visualization is a key part of graph analytics. Are there subgraphs within my graph where the vertices are more tightly connected to each other than they are to the rest of the graph? And then can I have a flexible schema that incorporates how different attributes are connected to each other and give me the ability to add a new attribute easily without changing the underlying database structure? So these are all some examples of using graph analytics for your business problems. And all of these powerful features are available as part of the Converged Oracle database. So you do not need a specialized database to work with graphs. You don't have to move your data to a specialized database to work with graphs. In the same database, when you do your relational work, when you work with JSON documents, when you work with geospatial data, temporal data, and so on, you can work with graphs. You can create a graph view. You can load this graph into an in-memory graph server and then work with it. So that's the real power of the Converged Oracle database, where all of these tools are available to you. So in Oracle Graph, which is the graph feature of Oracle database, we have two graph models. One is the RDF graph model that has been around since 2005 or so, has a mature set of standards coming from the W3C, and is used for data integration applications, linked open data applications, and to represent ontologies and so on in the knowledge graph context. And then you have property graph, the model, which is a newer graph model, has become very popular these days for doing analytics to get new insights into your data, like which are the most influential vertices? Are there anomalous patterns in my graph? Are there communities in my data? And so on. And both of these graph models are built on the enterprise capabilities of Oracle. So you don't need a specialized graph database, which will have some of the enterprise features and not have some of the other features. You can leverage all of the Oracle database features when you're working with these graph models. So now let's take a deeper dive into property graphs. So the property graph feature includes an in-memory graph server for highly scalable graph analytics and graph querying. As an example, which I will show later, one of our customers, Kesha Bank, has a very large graph with around 400 million vertices and about 2 billion edges. They're able to process that with ease, with very fast times by using this feature. The feature also includes a property graph query language, which is a SQL-like language for querying graphs. But when you query graphs, you need the ability to specify a graph pattern. You need the ability to specify a cycle or a path or any other pattern. And that is what the property graph query language gives you. This language is aligned with the SQL PGQ standard that's being worked on by the SQL Standards Committee, and we're planning to support that standard when it becomes available. The Oracle Graph feature also includes over 60 pre-built algorithms that can be invoked using a Java API or a Python API. So you don't have to worry about writing your own algorithms. These are available for you to use with your graph. So you create your graph, and then you can run these algorithms on your graph and then query your graph using PGQL. And of course, we have client tools and the graph visualization tools and so on. So let's see how you would create a graph from tables that you have. So let's say you have a bank accounts table with a list of account IDs and a bank transactions table. And every time you have an account transfer from between two accounts, that becomes an edge in your graph. So going here from account ID 1 to account ID 672, that's an edge, and you have a property of 1000, which represents the amount that's being transferred. So in a property graph, vertices can have properties and edges can have properties. So here, 1000 can become a property of that edge. Here's another edge based on another transaction. So once you determine your vertices and edges, if you want to build a graph, you can use that using the PGQL DDL syntax. So you create a property graph, you specify by specifying your vertex tables and edge tables, and specifying the source and destination vertices for these edges. So you can see here that you have a compact representation for doing all of these things. And when you execute this statement, you create a graph. And this graph can be a view on your tables. You don't have to replicate this data in a separate in a separate storage area for the graph. You can have a property graph view on these tables and run queries against this property graph view, or you can load this into the in-memory graph server for query and analytics. So now let's take a look at the property graph query language. So I said it's a SQL-like language, and this means it has constructs that are familiar to SQL developers, like select, from, where clause, and so on. And in addition, it has the ability to specify the match clause, a graph pattern in the match clause. So you can see here that this is selecting all edges that connect to vertices. So A and B in parentheses represent or variables representing vertices. E1 is a variable representing an edge because it's in square brackets. So you're basically saying here, find me all edges, because any edge is going to connect to vertices. So you're saying, find me all edges in the graph. It's something like select star from tab. This example, the graph pattern is a little more interesting. You're starting with a vertex A that connects to vertex B, that connects to vertex C, and then connects back to A. So this is a cycle that goes through two intermediate nodes. In other words, it's a 3-hop cycle. So you're looking for all 3-hop cycle in a graph, and you're representing a 3-hop cycle using this graph pattern. In this example, you're once again looking for edges in the graph. You're selecting edges in the graph, but you're qualifying the type of vertex and the type of edge, because the graph can have different kinds of vertices and different kinds of edges. So you're qualifying that by saying, I want edges that connect a vertex of type account via an edge of type transfer. And in this example, you have an additional where clause and an additional regular expression. So you're saying, I want to start with an account of type, with a vertex of type account, where the account holder's name is Nikita. And I want to look at all paths that are available from this particular account. So the transfer star indicates 0 or more hops of edges with the label transfer. So you're looking at all paths basically that are outgoing from Nikita that are 0 or more hops long. So you can see how we can specify more and more complex patterns using this language. We maintain this website, which gives you a comprehensive introduction to the PGQL language and all the details of various constructs that are available. Moving on to analytics, graph analytics is a way to analyze the entire graph by running algorithms on the entire graph. Some of these algorithms are run recursively on all the vertices in the graph and so on. So the different categories you have here are a set of algorithms for detecting communities, a set of algorithms for detecting importance in a node. For example, the PageRank algorithm will detect how important a node is by looking at whether that node or that vertex is connected to other important vertices. So in social network analysis, this would be the equivalent of saying a vertex is important based on who that person knows rather than how many people they know. Pathfinding algorithms, various flavors of pathfinding algorithms, such as the shortest path algorithm like Bellman-Ford, Dijkstra, and so on. And then machine learning. So machine learning graph algorithms give you the ability to include graph constructs within your machine learning algorithms. And that's a very hot area of research. And there are several new algorithms being developed in that area. So you're looking at connections in your data entities and including that in your machine learning training processes. So we support some of these algorithms as part of the Oracle Graph feature. So here are examples of how you would invoke the analytics API. If your PageRank, between a centrality, whom to follow, there's some examples, simple API calls. And when you run these algorithms on your graph, properties are created on each vertex, typically, that contain some value. For example, PageRank will return a value of between 0 and 1 for every vertex in the graph. Higher that number, more important is that vertex. So these become properties in your graph that you can then use in a query. So here in this PGQL query, I'm selecting account IDs and the PageRank value from all vertices, and then I'm ordering them in descending order. So I want the most important vertices to be listed on the top. And you can use the PageRank values in your visualization also. Our graph visualization tool allows you to specify conditions whereby you can say, if a vertex has a higher PageRank value or a value greater than something, I want that vertex to be displayed differently, like here in a brighter red circle. So you can use the analytics results in your query, in your visualization, and so on. Now let me move on to RDF graphs. So RDF graphs have a variety of use cases, and I'm going to explain one example. So it's used to represent information about a particular domain. Also can be considered as an ontology. So let's say in a university context, you have these categories of classes. You have a student is a type of person, a professor is a type of person, a graduate student is a type of student, a student takes a course, a graduate course is a type of course, a professor teaches a course, and so on. So this captures information about what happens in a university context. So when you have a new student coming in, Jane, who takes course CS 456, which is a graduate course, you can derive automatically using rules that are part of the RDF standard the fact that Jane is a student, because Jane is taking a course. This course is a graduate course. A graduate course is a type of course, and students take courses. So if Jane is taking this course, Jane must be a student. And Jane must be a person because a student is a type of person. So this is a very simple example, but it gives you an idea of how you can have an ontology to represent knowledge in a particular domain and use that to infer new relationships from your data. So we have comprehensive support for RDF based on the W3C standards. Sparkle is a query language that comes from the W3C standard, and we have full support for Sparkle. We can run Sparkle queries in the database, and this has been proven to scale to billions of RDF triples. For example, one of our customers, the National Statistics Center in Japan, had, when we last checked, about 2.1 billion triples, and they had an average Sparkle query response time of 1.27 seconds. And it was the same when they had 1.1 billion triples as well. So the system has shown that it can scale really well. So we have support for various tools like SQL Developer. You can create a Sparkle endpoint, meaning you can send Sparkle queries over HTTP. That's another thing that RDF developers like to do, because when you're linking data from different sources together, when you're querying data in other open repositories, you want to be able to send your Sparkle query over HTTP. And we have support for loading from a variety of formats, and also for the R2RML specification, which helps you create RDF graph views on relational tables. So SQL Developer is a popular tool for developers who know SQL, and we have a plugin for Sparkle, so you can use a familiar tool to run Sparkle queries against RDF data in the database. We also have an RDF graph server and an RDF REST API. You can use this to stand up a Sparkle endpoint, as they call it, so that you can send requests via HTTP to be processed by this endpoint against data in the database. It also includes a visualization component. So you have a comprehensive set of tools that you can use when you're working with RDF graphs in your applications. And RDF graph developers are like a few development environments, and we have adapters for those environments, like for Eclipse RDF4J and Apache Jena. So you can store your RDF data in the database and use any one of these development environments, given the adapters that we make available for these environments. So Oracle Graph can be deployed in an autonomous database as a fully managed service. The feature is available. You can also deploy it, let's say, in a database cloud service, that's in a co-managed service in Oracle Cloud, or in a user-managed system. So whatever your deployment choice for your database, the Oracle Graph feature is available. So let me move on to some customer use cases. So Kesha Bank is has one of the largest graph sizes when it comes to property graphs. It's using a graph to model customer behavioral patterns. They identify where customers use their credit cards. For example, if two people use their credit card at the same place within seconds of each other, it might mean that these two customers had lunch together. So that's a relationship between two customers. So they build their graph from data such as this to identify customers with similar behavioral patterns based on clustering and community detection algorithms. And because of that, they're able to more effectively identify what products will be of interest to these customers. So in addition to the over 60 pre-built algorithms that we have available, customers can also have their own customized algorithm or modify an existing algorithm, and Kesha Bank has done that for some of the specialized community detection activities. Here's another customer from Japan who provides a service of managing security, user security information within the organization as to which group a user belongs to from a security perspective and what assets they have access to. And this can become a complex hierarchy, and you need to keep track of who belongs where and what assets they have access to, and they manage this as a graph. And here's a very interesting example from a company whose business is focused on helping enterprises move their legacy software systems to a more modern system. They use graphs to model different components in the legacy system, like identify software objects that are used frequently, identify software artifacts that are linked to business processes, and identify which software artifacts are linked to which business processes, find software modules that are clustered together, identify similar patterns, and so on. And they're finding that graphs are helping them do this in hours rather than in days. So that's a huge advantage for them. Because finally, how data flows and how these software modules are connected to each other is a graph, and they're able to take advantage of that. And the Kesha Bank, another Kesha Bank example, where they're using RDF graphs for catalog management. So they have a database structure where they have where they store information about the product catalogs, and every time they have a new product offering, like a new credit card or so on, they need to be able to generate new asset information, and there could be new attributes, and they don't want to change the underlying database structure. They just want to be able to have a flexible schema that they can easily use to generate a new product catalog from the attributes that they have, the new attributes that they have added, and leveraging the relationships between these different attributes. And the RDF graph model is a really good fit for them there. So now moving on to customer testimonials, we are very proud of the fact that these customers have been able to see real value in their businesses by using the Oracle Graph feature. So they're able to provide added value to their customers, as the Chief Data Officer of Kesha Bank explains here. So as I said, they have a very large graph deployment, and the performance has been really outstanding for them. Paysafe is another company that is focused on managing payments, focused on the gaming industry. So they were able to use the graph feature to identify anomalous pattern and detect behavior that needs to be tracked further. And this was something they were often doing before with pen and paper, or just working with or to other processes which are quite slow, and they're able to bring that down to under a second now. So we have various assets on their use case. So I encourage you to go and check out this use case as well, and the Kesha Bank use case as well. They've both done tech casts with us and so on. So there's a lot of information available on details of these customer use cases. So we have a ton of resources to help you get started with graphs. We have our oracle.com page. We have several live labs available, the AskTom series. We keep adding new content to that. We have our blog. We have a YouTube channel and some of our social media handles. So I encourage you to take advantage of some of these resources and get started. And we also have a hands-on lab as part of Oracle Database World. And there you will be able to use the Graph Studio feature of Autonomous Database to create a graph, query a graph, analyze a graph, visualize the results, and so on. So in 90 minutes, you'll get really familiar with the graph feature. So I highly encourage you to join us in that hands-on lab. And thank you very much for joining me here today. I hope you enjoyed the session. Thank you.